Now we will see various properties of Fourier transform. So there are few properties of Fourier transform. First property is linearity property. So this property says that if suppose any function f1t is having Fourier transform f1 omega and f2t is having Fourier transform f2 omega, then a f1t plus b f2t has a Fourier transform a f1 omega plus b f2 omega, where a and b are any arbitrary constant. That means if you multiply any function with any arbitrary constant, it does not affect the Fourier transform. They will simply multiply with the Fourier transform of their respective functions. Here, this bidirectional arrow indicates that f1t has a Fourier transform f1 omega. So, whenever or wherever I will put this bidirectional sign, it always indicates that has a Fourier transform. So, this is what a linearity property states. Similarly, scaling property. Scaling means you are actually increasing or decreasing the content of any function. So if ft is having Fourier transform f of omega, then f of at is having Fourier transform 1 by a f of omega by a. That means this frequency is divided by the same constant which is multiplied at the time domain, and it is also divided in total. Then third property is time shifting. Time shifting says that is ft has a Fourier transform f of omega, then f of t minus t naught has a Fourier transform f of omega e raised to the power minus j omega t naught. Same as time shifting, we have another frequency shifting property which says that ft has a Fourier transform f of omega, then e raised to the power j omega naught t into f of t as having Fourier transform f of omega minus omega naught. Here you remember one thing, if in time shifting you can see that if it is subtracted, exponential term is negative. If it is added, it will be positive. Whereas in frequency domain, it is just the reverse. You can see that e raised to the power j omega t is positive quantity. Here frequency shift is negative, and when it is minus, it will become plus. So it is just reverse of time shifting. So this thing you keep in mind. And finally, one more property is convolution property, which says that if ft has a Fourier transform f1 omega and f2t has a Fourier transform f2 omega, then f1t convolution f2t is having Fourier transform f1 omega into f2 omega. That means in time domain, both the functions are having converged, and then in frequency domain they are simply multiplied. Here a simple multiplication is there, and here convolution is there. Now you will ask, what is convolution? So convolution means f1t convolution f2t is integration over the limit minus infinity to plus infinity f1 tau f2t minus tau t tau. This is how you can calculate the convolution of any two sequences. If you have been given two sequences, you can calculate the convolution by using this formula. So first you calculate the convolution, that means with the help of this formula, and then you will calculate the Fourier transform of this. Once you calculate the Fourier transform of this, you will get f1 omega into f2 omega. That means their respective Fourier transforms simple multiplication. So all these properties are understood, I think. Now in the next video I will explain the proofs of these properties and the Fourier transform of various functions. I hope the basic of this unit which we have started is understood to you. In the next video we will see the proofs of various properties.